differentiation and what are the techniques of differentiation. The meaning of differentiation. In mathematics, the process of finding the derivative or rate of change of a function is known as differentiation. Even the theory is quite abstract, the actual process is more practical and usually be done by using algebraic rules and techniques.
For question 1, we are looking at the different techniques of differentiation. There are 6 main techniques that we commonly use. The first one is the power rule, which is used for basic polynomial terms. Next, the product and quotient rules are applied when functions are multiplied or divided. Next one, we have the chain rule, which is used for composite function, and implicit interpretation is used when the equation involves both x and y. Lastly, linear approximation allows us to estimate function values using the tangent line. All these techniques help us differentiate different types of function depending on the structure.
Hello everyone, today we want to solve question 2 where we need to find the derivative of two given functions. For part A, we are given y equals to tan of x cubed e to the 4x. First, recall that the derivative of tan is dy dx equals to secant squared. First, that u equals to x cubed, u prime will be 3x squared. V equals to e to the 4x, v prime will be 4e to the 4x. After substitute, the derivative will become secant squared of x cubed e to the 4x multiplied with 4x cubed e to the 4x plus 3x squared e to the 4x. After expand, we will get secant squared x cubed e to the 4x multiply x cubed times 4e to the 4x plus e to the 4x times 3x squared. Then we factor out the common. We will get secant squared of x cubed e to the 4x multiply e to the 4x times 4x squared plus 3x. 4x cubed plus 3x squared. The final answer, we will get dy dx equals to e to the 4x secant squared of x cubed e to the 4x multiplied with 4x squared x cubed plus 3x squared. To differentiate fx equal to 3 minus 4x over ln 2x. First, we let u equals to 3 minus 4x, so u prime will be negative 4. V equals to ln 2x, v prime equals to 1 over x. Since we use the quotient rule, we substitute, then we will get f prime x equals to negative 4 ln 2x minus bracket 3 minus 4x times 1 over x over ln 2x squared. After we simplify, we will get f prime x equals to negative 4 ln 2x minus 3 minus 4x over ln 2x squared. Then, after we simplify the negative sign, we will get f prime x equals to negative 4 ln 2x minus 3 over x plus 4 over ln 2x squared. So the final answer, we will get f prime x equals to 4x minus 4x ln 2x minus 3 over x ln 2x squared.
Question 3. Given x squared cos y plus ln x over y minus 2x equal to exponent e power of 1 minus 2x, find dy dx using implicit differentiation. X squared cos y plus ln x over y minus 2x equal to exponent power of 1 minus 2x, which is a plus b minus c equal to d. We will divide into 4 sections. Let a equal to x squared cos y. To find a prime, we need to use product rule, which is a prime equal to u prime v plus uv prime. Let u equal to x power of 2. We need to use power rule. We bring the 2 down and the power will minus with 1. We will get u prime equal to 2x. Let v equal to cos y. For this, we need to differentiate with respect to x. And for the cosine, the derivative will get negative sin. And since y depends on x, we need to multiply with dy dx. So the answer, we will get v prime equal to negative sin y dy dx. And next, we will substitute into the formula of product rule. 2x cos y plus with x squared minus sin y divided x, we will get 2x cos y minus x squared sin y divided x. We will get this after we expand the number. Next, let b equal to ln x over y. We will get ln x minus ln y. This we will use the law and we will get b prime equal to 1 over x minus 1 over y, and it is the same like plus 1. Since y depend on x, we need to multiply with divided x, and then let c equal to 2x. After differentiate, we will get c prime equal to 2. Let d equal to exponent power of 1 minus 2x. To find d prime, we need to use the chain rule and differentiate it. We will get exponent 1 minus 2x negative 2. We need to multiply them, and then we will get d prime equal to negative 2 exponent power of 1 minus 2x. Next, we need to sub into formula and solve. The formula is a prime plus b prime minus c prime equal to d prime. We get 2x cos y minus x squared sin y divided x plus 1 over x minus 1 over y divided x minus 2 equal to negative 2 exponent power of 1 over 2x. And we will collect all the divided x into one side. We get negative x squared sin y divided x minus 1 over y divided x equal to negative 2 exponent power of 1 minus 2x minus 2x cos y minus 1 over x plus 2. And then we will collect, and then we will factor out divided x. So we will get minus x squared sin y minus 1 over y divided x equal to negative 2 exponent power of 1 over 2x minus 2x cos y minus 1 over x plus 2. dy dx equal to negative 2e power of 1 minus 2x minus 2x cos y minus 1 over x plus 2 over negative x squared sin y minus 1 over y.
For question 4, use linear approximation to estimate the value of 2 over the cube root of 64.02 plus ln of 64.02 correct to 4 decimal places. For the first step, we'll have to find x naught, x, changes of x, fx, and fx naught. Firstly, we'll have to set x as 64.02 and choose x naught as 64, which make changes of x as 0.02. Next, we'll have to define the function of f of x equals 2 over the cube root of x plus ln of x, which make the fx naught equals to f64 equals to 2 cube root of 64, which make it 1.5. Ln 64 would be 2 power of 6, which make it into 6 ln 2. Then we will evaluate the function f64, which make fx naught equal to f64 equals to 1/2 plus 6 ln 2. Second step, we'll have to find f prime x and f prime x naught. So in step 2, we'll have to differentiate the earlier function, and then we'll get f prime x equals to negative 2x to the power of negative 4x plus 1 over x. Then we'll substitute x naught equals to 64. So f prime of 64 would be equals to 5 over 384. Lastly, for the third step, which is the last step, we'll have to apply the formula of linear approximation, which is fx approximately fx naught plus f prime x naught times changes of x. After substituting all the values, f of 64.02 is approximately 4.6591, correct to 4 decimal places.
So the conclusion is differentiation is the process of finding derivative, which tells us how a function changes at any point. It is based on the concept of limits, and it is one of the core ideas in Calculus 1. Differentiation helps us to understand the rate of change, solve real problems like optimization and motion. Lastly, mastering techniques like power rule, chain rule, and product or quotient rule allow us to analyze and model any different types of functions.